Today we're going to be looking at some example problems for projectiles. A couple of quick reminders that we have. Remember that we have horizontal and vertical components to our different projectiles and that those two are independent from one another. So our X and our Y are independent, meaning that we cannot use information from one to affect the other. So if I know how far something goes, that doesn't really tell me how high something goes. If I know how fast it's moving forward, that doesn't tell me that it's moving, how fast it's moving up or down. The only component that we have that can go between the X and the Y is time. So time is something that will work for both our horizontal, or X components, as well as our vertical, our Y components. Recognizing this as a rule, I want to find time first, because that's going to be the only way that I can figure out the rest of my information. As some reminders with that, we've given you kind of a little table here, and you'll notice as you go down the page, we started doing less and less in that table for you. That doesn't mean you can't add it back yourself. And then when we get over to the other side of our page, you'll see that we didn't create that table for you, but again, that doesn't mean we can't create it for ourselves. In the middle, we have that time, again to remind ourselves that that time that it takes to fall down is the same amount of time that I have to move forward. So that time is the only thing that is consistent. To figure out how to solve for time, I need to read my different questions and statements to see what information I have and what equation to use. From our formula chart, we have the following equations. So I just moved them off of y'all's formula chart and put them onto mine. So if I'm finding time, I want to either use this one, or this one to make that happen. So by labeling, I can figure out what information I have and which of these time formulas to use. So we have a meatball that rolls off of a plate that is on a 5-meter tall table. So 5 meters tall. If I'm tall, that's vertical. So that would be a Y distance. And it lands 0.75 meters away. Away, forward. That's an X distance. And that's the only information they've given me. So if I come over and I look, in order to use this equation, I would need an X distance and an X velocity. I don't have an X velocity, so I can't use that equation. To use this one here, I would need a final velocity and initial velocity. Well, I don't have either of those two, so I can't use that equation. I do have a vertical distance, and I know what gravity is all the time, so I can solve for this. So I can figure out the time that it takes for my meatball to fall using our T-fall equation, 2 times the Y distance divided by our acceleration of gravity. So to solve for time, I am going to simply plug in my variables, 2, and my Y distance is 5, not 0.75. So 2 times 5 divided by that negative 9.8. Okay. We've discussed before that I cannot square root a negative, so I need to drop the negative in my calculator because time can't be negative anyway. So I'm going to drop that negative out and when I put it into the calculator. So square root of 2 times 5, well 2 times 5 is 10. So square root of 10 divided by that 9.8, I'm going to come up with 1.01 seconds. So that's my time. Again, I know that my height, my vertical distance was 5 meters. I know that my horizontal distance was 0.75 meters. And now I can go and start to solve for my remaining things. Because I'm falling, I know that my initial velocity in the vertical direction is 0. That does not mean that my initial velocity horizontally is 0. I can still be launched, but at the top of my vertical path, my velocity is 0. And I know that I have gravity accelerating me down. Horizontally, I don't have any acceleration going down, meaning that my initial and my final velocity should come out, and they're going to be the same number. So let's start solving for some of these variables. If I want to find my final velocity, I'm going to go back to my equations over here and start picking and choosing. So for final velocity, I have this one and I have this one. I now have my time. I also have my distance. So realistically, I can pick either of these two equations in order to solve for it. Most of y'all tend to prefer the one without the squares, but again, it should not matter which one I use. So if I want to solve for my final velocity, my initial velocity up at the top was 0. I'm going to do plus my acceleration of gravity, negative 9.8, times my time, 1.01. So 9.8 times 1.01, simply plugging that into my calculator, I come up with 9.898, or 9.90 if I round. And because this is negative, it is falling down. If I want to solve for my horizontal velocity, well, the only equation I have with horizontal velocity would be this one. So I need my horizontal distance, which was 0.75, and I need to divide that by my time, which in our case was 1.01. So 0.75 divided by 1.01 is going to give us a horizontal velocity of 0.743, or 0.74 when we round. Again, because we're not accelerating, we're not decelerating, our horizontal velocity is always going to be constant. So both my initial and my final would be that 0.74 meters per second. For my next problem, a slingshot fires a rock horizontally with a velocity of 5 meters per second. So that is, as they said, my horizontal velocity, or my Vx. The rock lands a horizontal distance of 30 meters away. Again, away is usually my key word that I went forward. So that's going to be my horizontal distance. As I said earlier, find time first. So with these two values, I want to come over and look at my equations and decide which one I can use to find time first. So I can no longer use my T-fold equation because I don't have that vertical distance, only the horizontal one. I don't have any I don't have any vertical velocities, so I can't use that one. The one that I can use is my horizontal distance divided by my horizontal velocity. So my time is equal to my dx divided by my dy. Divided by my vx. So my time equals distance of 30 meters divided by a velocity of 5 meters, meaning that our slingshot is going to fire a rock, and that rock will stay in the air for 6 seconds. If I know my time, I can then go and calculate my other stuff. So vertically, my slingshot has fired something horizontally at that 5, but my vertical velocity, that initial velocity, is 0. So my initial velocity is 0 because it starts at the top and falls down. That means to find my final velocity, I need to know that my acceleration is because of gravity. And so when I come up, final velocity, well, I don't yet have the distance. So this equation that I used earlier is probably the easiest one I can use for now with the information that I have. So my final velocity is equal to my initial velocity plus my acceleration of gravity times my time. Again, our initial velocity is 0, so I don't need that component anymore. We decided a second ago that our time was 6. So 9.8 times 6 seconds is going to give me my final velocity. A little calculator work, and it comes out as negative 58.8. That negative is because it's falling down. To find my height, or my vertical distance, I need to pick an equation that has a vertical distance in it. Going back to my equation chart over here, this has a vertical distance, this has a vertical distance, this has a vertical distance, and of course my t-fall has a vertical distance. So I'm going to pick the one that seems easiest. This one is already set up for dy, where I don't have to do any algebra. To me, that is the easiest equation to use. So my vertical distance, or my height, is equal to my initial velocity plus my 1/2 times my acceleration times the time squared. And again, we start at rest, so I don't need this part. I can simplify my equation to show us how far we're falling. So I can always kind of cut out that part when we're falling. So 1/2, or if you prefer, 0.5 times my negative 9.8 times my time squared. This comes out to show me that my slingshot fired that rock 176.4 meters into the air. And we'll take the positive or the negative version of this. As a height, it's probably positive. If we're looking at the distance that it falls, it's negative. So we can go either way for most of these problems. For my next one, an arrow is shot at a target and strikes the center bullseye. So I'm going to shoot my arrow forward at my target. As it goes, it's going to slowly start to fall down. The arrow strikes the target with a downward velocity of 4 meters per second. So that's my final velocity. So I'm striking the target there. And a horizontal velocity of 55 meters per second. So that's my x velocity. When it started, it still had a horizontal velocity of 55, but it had a vertical velocity of 0 because it wasn't yet falling and it was definitely not rising. So my initial velocity would be 0. And of course I have my gravity, my negative 9.8. So these are two numbers that are essentially implied on my vertical side over here. As we discussed earlier, we want to find time first. So I'm going to go back up to my equations and start to look for which one will allow me to solve for time. So if I wanted to use my first time equation on top up here, I have the x velocity. I do not have the x distance, so I can't use that one. I have my acceleration of gravity. I know that I started at rest, and I know I finished at -4. So I can use that one. Just to double check, I don't have my distance in the y direction, so I cannot use that one. So the equation that I have enough information to use is going to be this one, where my time is my final minus my initial divided by that acceleration of gravity. So -4 minus 0 divided by our negative 9.8. Subtracting 4 doesn't do anything, so -4 divided by negative 9.8 will give me a positive number for my time. My time comes out to be 0.41 seconds. The last thing, let's see, so the next thing that I need to solve for is either my height or my distance. I can pick whichever one I want to start with. So my height, or my vertical distance, again, the easiest equation I have is going to be the one I used earlier, where my vertical distance is 1/2 times my acceleration of gravity times my time squared. A little bit of calculator work. Take a second, try it out. Should come out as 0.82. So our last thing to solve for this problem will be our horizontal distance, or our dx. To solve for dx, I need to know the horizontal velocity as well as the time. So dx equals our velocity times our time. My horizontal velocity was 55. My time was 0.41. So I simply put that in my calculator. Go ahead and try it out. And that horizontal distance should come out to be about 22.55 meters. If the tables make sense for you, then use them. For some of you, a simple picture helps it make sense. But you need to decide what works for you. The most important thing to get into first is find that time first. If we look at the number of our equations that include time, then we quickly see that time is it's a universal for the fact that it can cross from both the y to the x, but also looking at how many of my equations have time. By knowing time, it makes it much easier to solve for the rest of my equations. So since time is in the majority of my equations, since time is the thing that can cross from the x to the y, it's important to know. All right, for a few more example problems, let's go ahead and take a look. A cannonball is shot straight up out of a cannon that is in the bed of a truck traveling at a constant speed. We saw an example demo pretty similar to this. So my cannonball is going to be fired up with a velocity of 39.2. That will be my initial velocity. When it gets to the top, my final velocity in that y direction will be 0 before it starts to fall down. So that top velocity is 0 in the vertical direction. Now if my truck started out going 3 meters per second, then that cannonball is also going 3 meters per second. And then still at the top of its path, it still has a horizontal velocity of 3 meters per second. So our x velocity is constant. We want to know how long it will take for it to reach the top of its path. So at the top of its path, I know that my final y velocity is 0. We have our initial y velocity, and how long, that's a time. So looking at my equations, I have a final velocity, an initial velocity. Of course, I know acceleration due to gravity, so I can calculate the time. My time is my final minus my initial divided by the acceleration of gravity. 0 minus our initial, 39.2, divided by our acceleration of gravity, negative 9.8. Take a second, do your calculator work. So it will take about 4 seconds for our cannonball to get to its highest point. What's the total time of the cannonball in flight? Well, if it takes me 4 seconds to go up, then it should take me 4 seconds to go down. So my total time will be 8 seconds. How high did the cannonball get? Well, the highest point is going to occur in that first 4-second mark. So my time is 4 seconds. I know my y velocity at the top is 0. I know my y velocity that it started with was 39.2. And I'm using the y velocities because high is a y distance. So remember, I can't use any information from the x-axis to solve for the y. So if I'm going to pick a y distance, here's a y distance, there's a y distance, there's a y distance, there's a y distance. So based off of this information, the one that I can do, if I can use this equation where distance is already by itself, that's the one I want to try. So 1/2, I have that. Acceleration, that's gravity. I know the time that it took to get to the top. In this case, I want to use the full formula because we did start with a velocity. So my equation will be my y distance is the initial velocity times time plus 1/2 times gravity times my time squared. So 39.2 times 4 plus half times my negative 9.8 times 4 squared. You can do that all at once, or you can type it in piece by piece, your choice. If you go piece by piece, this is 156.8. 0.5 times negative 9.8 times 4 squared is going to give me a negative number. $78.4. So I'm subtracting those two. And it comes out as a positive number because it went high, up in the air. From our demonstration, relative to the truck, where is the cannonball going to land? So when my cannonball comes back down, it left my truck here. It moved with a constant speed forward. So if my truck kept moving forward at a constant speed and my cannonball kept moving at a constant speed the whole time, it should end up right back in that cannon in the truck. No picking on my truck. Quit laughing. Alright, the next thing that we're going to solve for, what's the horizontal distance? So how far did our truck travel in that time? So it left here, it took 4 seconds to get up, 4 seconds to get down. So if I want to know the total distance forward that it traveled, I'm going to use my total time, the whole 8 seconds. My x velocity, because I'm going horizontal, was 3 meters per second. So to find my horizontal distance, I'm doing velocity times time. Horizontal distance is the horizontal velocity times the time. 3 times 8 will give me my horizontal distance. Try it out. Should come up with 24 meters. What is the resultant velocity? Remember that the resultant is a combination of the x and the y. So when that cannonball landed, it was moving down with a speed of negative 39.2. It was moving forward with a speed of 3 meters per second. So we want to know that in between, or that combination velocity. So my resultant velocity is my x velocity squared plus my y velocity squared. I'm going to take the square root of that final answer. My x velocity was 3. My y velocity was 39.2. And because I'm going to square it, it's not necessary to use the negative. And I can't put the negative under my square root anyway. So 3 squared and 39.2 squared, the square root of that. Go ahead and try it out in your calculator. Should come up with 39.31 meters per second. When that ball comes down, it is going down. So we do want to apply that negative to our answer. What is the resultant velocity at the highest point? Let's think back about that picture from up above. At the highest point, I'm not rising or falling, so my y velocity is 0, but it is still moving forward, so our x velocity is 3. So our resultant velocity is the x velocity squared plus the y velocity squared and the square root of that final answer. So 3 squared plus 0 squared, when we take the square root, it's going to come right back to that same 3 meters per second. So that's the only velocity that it had at the top. That is what my result would be, or what my combination would be. Thank you for your time. I hope this makes sense. Please ask questions. Please try this out. Remember that you have horizontal equations, you have vertical equations. Time is the only thing that you can take across those two parts. So time is the only thing that can cross the border parts there. Otherwise, you have to keep your distances on their axes. You have to keep their velocities on their axes. They do not get to go back and forth because they are independent of one another.